Okay, got several questions for this office hour session. And the first one is 5.2, number 25/7. Graph the function and support the sketch with the calculator graph. Give the domain range an equation of the asymptote. Determine if f is decreasing or increasing. Well, I'm not really worried about all that because y'all know how to do that. But we know this function is 2 to the x. It's in the family. And what I'm going to go ahead and tell you in this section, you remember back when I showed you the family of graphs and I told you to write a piece of notebook paper and have several, and I think there was maybe a couple of spaces that you didn't have filled out right here and right here, or you need to add 2 more. You need to add f of x is equal to e to the x. Do that on your calculator and graph it, and it'll look something. E to the x will be upward, and f of x is equal to 2 to the x. All right, so if you want to know what they look like, just take your handy dandy calculator, pull it up. If it'll let me pull it up. I hope it'll let me pull it up. There we go. And y is equal to second e to the x, close parentheses, and that's show you what that one looks like. And that's what it looks like. Looks like it's taken off from 2. So you would just write it something like this right here. Something like that. And then 2 to the x. Well, I thought I had it pulled up, but evidently, there we go. Try it again. And y is equal to second or caret symbol x and graph. And it looks about the same. Okay? So, or e to the 2x. So it's about the same graph. So you can just draw it again over here if you want to. The main thing is you need to add these two so you know what they look like. They look about the same. All right? So you know that the function is going to look something like this. All right? So you go to the handy dandy graph thing here and you click on it. I'm not very familiar with it. And you know that your function swoops up, so you would hit this function and tap on the graph, and there it is. Now, you can change this to a 2 if you wanted to, but it's the same thing. You're going to see backspace, change that to a 2. Well, it's not letting me change it. Really? Well, save, hit enter, check answer. Okay, it wants the 2. That's what it wants. So let me do it again. Oh, Lord. Backspace 2. There we go. And check answer. Well, for some reason it's not taking it. Oh, I forgot the 4. See the -4 up there? The -4 means it's a horizontal shift to the right. So you got to move, yeah, to the right 4 places. I messed up. There we go. Backspace 4. and check. There we go. Okay, I didn't clear the first one, but there it is. There's the answer right there. Okay, remember, if the function, if the x is tied to a number, that's your horizontal shift. If it's not tied to the number, if you had 2 to the x and then you had a plus 4 out here beside the 2 to the x, then that would be a vertical shift. It all goes back to the family of graphs. Now, what's the domain of this function? Well, the domain is from negative infinity. Looks like you got a going down to 8. Looks like it's going to 8. Pull it up and we'll see. Looks like it's converging, it's passing 7. Looks like it's converging onto 8. So I would say your vertical asymptote is probably at 8. That's your vertical asymptote. Okay? And of course, you'd have to punch it in a calculator to see if it gives you a do not exist. But I can show you how to do that in just a second. So you just have to play with the, graph writer or whatever you call it, graph drawer or whatever it's called, graph editor. Change this x minus 4. I mean, just set that, what can you not have? Well, you don't want it to be 2 to the what power is equal to negative. You don't want that. So that's why you get 8, pretty much. If you was to put 8 there, you would get 8 minus 4 is 2. That'd be 2 to the 4th power. So the domain is going to be negative infinity to 8. Okay? The range is from 0 to infinity. It's increasing from negative infinity to positive 8. It's increasing. Okay? And it is an increasing domain because it's increasing from left to right. It's increasing. These take a little bit. What I would suggest you do is use your graphing calculator. Okay, use your graphing calculator to guide you on these. Okay, because this graphing editor is too complicated. I mean, go ahead and get the answer correct. Play with the graphing calculator. The graphing editor. Play with it until you get it right. But don't focus on the graphing editor that much. Use the calculator to help you get the right answer on the graphing editor. All right. The domain, once you look at it, just look at it. If you look at it, you can see the domain is negative infinity to positive 8 because it's starting to converge onto 8. And the range is from 0 to infinity. And it's increasing because as you go from left to right, put your little car right here. What's happening to that car as you go from left to right? It's increasing. Okay? So that's that question. And I'm not trying to be vague. It's just that this question is... I don't really like the questions about the graphing editor because the graphing editor is a pain to some people. So that's why I like to tell students on the test, try to use your graphing calculator to guide you on those, okay? All right, this is 5.233/8. Same type, 2 to the x. Again, you've got a graph. Use your graphing calculator to do 2 to the x. But this is 2 to the x minus 2. Now that 2 is not connected to the x, so that means it's a vertical what? Vertical shift. If it was tied to the x, it would be 2 to the x minus 2. And then that would be a horizontal shift of 2 to the right. It all goes back to that family of graphs, and it all goes back to that, how is it written? Okay? So this is a vertical shift. You know that the actual looks like that. All right, so it's going to have a vertical shift of 2 down. So it's going to be crossing right in there. So it's going to be looking like that. So you would put in there 2 to the x, and then you would put in a vertical shift of 2. That's how you would do it. So you would click on to the editor, or whatever you call this thing, and then click on here. You know that there's increasing value, and click on it, and right here put a vertical shift of 2, and hit save, and hit check answer. And that's it. Now your domain on this one is negative infinity to, it looks like you're converging on to 4. 4 is your vertical asymptote. From negative 2 to infinity is your range, and of course 2 to the x and e to the x is always increasing. Okay? Like I said, let me show you an example. I'm going to show you what I'm talking about. In the family of graphs, way back, I told you f of x is equal to a times x plus h, quantity squared, plus k. F of x is equal to a square root of x plus h plus k. F of x is equal to a times x plus h, plus k. F of x is equal to a times x plus h to the 3rd power plus k. Okay, and you can add this. F of x is equal to a times x, or a to the, you could put x, oh Lord, hold on a minute. It started out as an eraser this morning. Now it's done changed. Okay, you could put a to the x plus h plus k. See, that's what you need to add. If you look in the book, you'll see this. Okay, this is in the book, probably in 5.2, but you got to look in the book. All right, that is what you need to add to the family of graphs that I told you to add. That graph that looks like this. This is your horizontal shift. If it's a negative, you go to the right. If it's a positive, you go to the left. And this is your vertical shift. It still applies to these. There's your horizontal shift. There's your vertical shift. There's your horizontal shift. There's your vertical shift. If you did E, that'd be f of x is equal to e to the x plus h plus k. Again, there's your horizontal shift, there's your vertical shift. They all fall in the same family of graphs. A, H, and K. A is your orientation, H is your horizontal shift, and K is your vertical shift. Okay? Next question. I think we're going to move into another section now. Get out of this one. 5.4. This is 5.45723. I think this is logs. Maybe. Oh, don't do this. Okay, for some reason it's not pulling that up. I don't know what, the moon is not right or something. Let me see if it pull up 5.5. Okay, there's something wrong with this stupid. Probably done logged me out of the emails. Hold on a second. I have to deal with this primitive stuff. Hold on, I'm gonna have to pause the video and find out what's wrong with the T-Rex computer system. Okay, this is the question I was going over, which I don't know what I did. All I did was get out of it and go back in it, so I don't know. For the exponential f, find the inverse function. Okay, these are pretty simple. First of all, I'm going to rewrite it as y is equal to 5 to the x minus 3. Now, switch the x and the y, so that's going to be, I'm going to put x is equal to 5 to the y minus 3. Now solve for y. So I'm going to solve for y, so I got to get rid of the 3. Take that across the river, and it becomes a positive 3. Okay, now I've got a to the y is equal to x. Now that's the definition of a logarithm. If you've got a to the y is equal to x, a to the y is equal to x, that means that x, or y, is equal to log base a of x. This is the definition of a logarithm. You should have gotten that in the definitions and properties of a logarithm in the videos where I explained the definition of a logarithm. In other words, I can rewrite a exponent as a logarithm, or I can rewrite a logarithm as an exponent. All right, so this is a exponent, so I'm going to rewrite it as a logarithm. So my a is 5, so that's going to be log base 5 of x plus 3, and y is equal to, y is equal to y. So that is the inverse function of, put -1, that's the inverse function of this function. And if you graph these functions, you see that this one has a vertical shift of 3 down. And you know it looks like 5 to the x, so it's going to be a little sharper turn, but it's going to be 3 down. So the first one is going to be right there, so 1, 2, 3. So it's going to look something like that. And then the other one is going to look the opposite. This one is going to be the inverse, which would be something like that. Okay? We'll graph it and see what it says. I don't know, because I don't know what it looks like. So let me erase that, and we'll go to the, let's see, how do I graph it? Let's see. Oh, this is just, we got to type it in. I'm sorry. So let's type it in. So I need to type in log base 5 of x plus 3. So that's going to be log base 5 of parentheses x plus 3. Okay. Now we're going to graph it. Now since the plus 3, okay, I forgot to add that. That's plus 3, that's tied to the x, that's a horizontal shift of 3 to the left. But let's go ahead and graph. We know what the first one looks like. And we're going to make that, it has a 5 to the x minus 3. That means a vertical shift of 3 down. So -3. And then we've got a log base 5. So we know that looks something like this, which would be this one. But it's got a horizontal shift of 3 to the what? Left. So I'm going to put -3. And there is your graph. Okay, I don't think I put in 5 to the x. But let me go back and change it. Evidently has an e to the x on the bottom. Clear. Yes, I want to clear it. I think it's defaulting to e to the x, and you have to change it. I'm going to do this one. Yeah, see the E down here? It's defaulted to E, so you have to backspace and hit 2, or what is it? 3, 5. 5 to the X, and then go up here, and your vertical shift is 3 down. There we go. And hit save. And then hit it again. And we're going to do the logarithm. See, it already goes to logarithm. Well, it should be logarithm. And we got a horizontal shift of 3 to the left. Wish it would cooperate. -3. But this needs to be the logarithm. I don't think it's going to do it. I don't think that's right. I don't know how to put the logarithm on a... That's not right. It needs to be the logarithm. Log base E. But how do you put logarithm in there? I don't know how to do that. Log base 5, LOG. See, it's not letting me type. It's not letting me... I have no idea what to put. Final check. Looks like I got the right answer. I'll have to look about that, but I don't know why it's not, because I got it same spot. Yeah, it looks like it's the same line. I'll have to check on that one. But this is how you analytically, this is how you do it. And you got to know the definition of a logarithm right here. Definition of a logarithm. When you have a logarithm, you can write it as an exponent. When you have an exponent, you can write it as a logarithm. That's how I finished. I got this right here to turn into this. And I put the -1 there to show that it's the inverse of this function right here. Okay, next one. 5.4, 61/24. So far, I haven't seen any test questions. These are just properties of logarithms and e to the x's. So I'm pretty sure I don't think any of these are going to be on the test. I'll tell you when we get to a test question. Okay, this one is saying, it's giving you the directions. It's saying f of x is equal to log base a of x. And they're saying that if I plug in 3 right here, f of 3, I'm going to get, for y, I'm going to get 6. So that basically means 6 is equal to log base a of 3. Now remember this, and remember this, because you're going to use it later. So I'm going to highlight that. Okay, remember that. Now, everything that you do needs to be in terms of that 3, because that's going to help you. All right, let's do f of 1 over 27. F of 1 over 27. Well, I need to write it in terms of 3. When you get this number right here, you got to think in terms of 3. So 27 is term, but I'm going to rewrite that 27 as 27 to the -1. I'm going to bring it upstairs like that. And 27 is 3 to the 3rd power. 3 times 3 is 9. 9 times 3 is 27. So I can rewrite that as 3 to the 3rd power raised to the -1. And that's equal to 3 to the -3, or 1 over 3 to the 3rd. So I just rewrote it. Now, Now I can rewrite that 3. And if I have that 3, see if I got this 3 like that, then I can use that with this right here. All right? How do you use it? Well, you can bring this 3. You can say that the 3 to the negative 3, I'm thinking how to get to the next step because of this. You end up bringing the negative 3 out. Hold on just a second. Let me refer to the book because I can't remember how to make that step. Hold on just a second. I'm sorry, I got sat down and I saw it. I can actually say that f of 27, 1 over 27, f of 1 over 27, if I was to use f of 1 over 27, and that's what that says, I'm going to plug that in, that 1 over 27, I'm going to plug that in, which is rewritten as 3 to the negative 3. I can say log base a of 3 to the negative 3. I just take that and I plug it in right there because I'm plugging in 1 over 27, 1 over 27, and 3 to the negative 3. So that's equal to, use your exponential law of logarithms, that's equal to negative 3 times log base a of 3. Now the log base a of 3 is your highlighted portion up here. And that's going to give us negative 3 times, what's the natural log equal to? Log base a of 3 is equal to 6. And that 6 comes from this right here. So that's your answer, negative 18. So f of 1 over 27 is equal to negative 18. All right, let's do 81. Now notice, I'm not erasing what's up there in yellow because you're going to use that for all of these. And all of them are going to be in terms of 3. So, f of 81. So 81 can be written in terms of 3. That 3 is what we got to focus on. So 3 times 3 times 3 times 3 is 3 to the 4th power. Therefore, f of 81, I'm going to plug 81 into log base a of whatever. I'm going to plug it in. So log base a of 3 to the what? 4th power, which is equal to 4 log base a of 3. Well, like I said, that's the highlighted portion, which is equal to 6. So 4 times 6, which is equal to 24. And that's what they got here. So all you have to do is rewrite 6 and 0 in terms of 3. Okay, well, how do you do that? Well, 6 is equal to 3. You got it as a multiple of 3 is 3 plus 3, or 2 times 3. So take that and work with that. I did the first 2, you can do the second 2. All right? So 2 times 3, or 3 times, 2 times 3, and work with that. 0, how do you get 0? Well, when you plug 0 in, that means that's going to be 0 to the 3rd power. 0 to the 3rd power is, or 3 to the what power is equal to 0. Well, that's kind of hard to do that. So take a minute and write those 2 down and try it. and I'll start the video back and we'll take it from there. So work on those two and I'll pause the video. Now, if you notice something on this C, that's not the same one we've been dealing with. What's different about it? Notice again, I'm leaving everything, and I also want to bring this up also. I want to highlight this again. Just remember that. That's how we got this. But this has something different. What's different about it? Well, these were F. This is what? F, the inverse. So I got to rewrite the inverse. I got to write the inverse of the original function. Okay? The original function is f of x is equal to log base a of x, or y is equal to log base a of x. And I'm going to switch them. X is equal to log base a of y. So that comes out to be, by the definition of a logarithm, a to the x is equal to y. Okay, if you solve that, you get that. So this is the inverse of that. Okay, so y to the negative 1. There you go. So y to the negative 1 is equal to a to the x. But they're saying here that negative 6 is x. So plug that in. Negative 6. So y inverse is equal to a to the negative 6. Okay? So that'd be 1 over a to the 6th. Wait a minute, plugging in negative 6. Yeah, plugging in negative 6 would give you, So, if I've got y is equal to negative 1, y to the negative 1 is equal to a to the negative 6, or f of negative 6 is equal to a to the negative 6, then of course that is a negative exponent. And of course you need to rewrite that. Rewrite that right quick. And see what you get. Now when you're doing this one, you actually have to think kind of in reverse, because this is a to the 6th. And you got to remember from this right here, f of negative 1 of 6 is equal to 3. Remember, when you do the inverse, you plug in y to get x. So I can easily rewrite this as f of 6, f negative 1 of 6 is equal to 3. Okay? Now, I can rewrite this as a to the 6th to the negative 1, and a to the 6th is 3, and that's going to be 3 to the negative 1, which is going to be 1 over 3. And that should be your answer. Okay? Now, you got to remember, this is thinking backwards. This is, remember, y is equal to x. Y to the negative 1 is equal to, or you got to do the opposite. You got to change x equal to y, or let me read the x squared. There we go. And then you got to change it to x is equal to y squared, and y is equal to square root of x. This is the inverse of this. Now you can rewrite this as f of x is equal to x squared. You plug in x, you get y. Here, it's f of negative x. I'm sorry, f to the negative 1 of x. That's the inverse. Okay, f to the negative 1 of x, f, or negative 1 right there, f to the negative 1 of x is equal to the square root of x. So it's kind of like the opposite, all right? So when you do this these two right here, you've got to remember, well, I can't write, but you got to remember that this says f to the negative 1. This right here says f to the negative 1 of 6. When I plug in 6, I'm going to get 3. And that's where you get this right here. Okay? And if I plug in, I can change the a to the negative 6. I can change that to a to the 6. Well, a to the 6 is equal to 3. Okay? So, not a very good question. This is a little bit too much detail for the logarithms. I wouldn't put this on a test. 0, the same. Okay? Except you're going to get negative 6. When you plug in negative 6 here, you're going to get that. So the last one would be plug in 0, and the natural log of 0 is 1. So again, not a very good question. I'll tell you when we get to a good question. Next one is 5.5. Number 81, number 21 in the homework. This is a test question. U substitution. U is equal to e to the x. So I could rewrite this as u squared minus 14u plus 13 is equal to 0. Well, there's only one multiple of 13, and that's 1 and 13. And that has to be negative, so the 13 has to be negative. This means like signs. So you've got u minus 1 is equal to 0. And you've got u minus 13 is equal to 0. Now plug in the u. E to the x minus 1 is equal to 0. E to the x minus 13 is equal to 0. E to the x is equal to 1. E to the x is equal to 13. Now, take the natural log of both sides, and you're going to get natural log of e to the x is equal to the natural log of 1. And natural log of e to the x is equal to the natural log of 13. And natural log takes that out, you got x is equal to 0. And take that out, x is equal to the natural log of 13. Okay? That is a test question. That's a good question. So make sure you know how to do it. And hit similar question and do a couple more like it. Good question. Next question. Next question is this one, which is the last one, 5.589/23. 89/23. And let's see, this one is a good one. Oh yeah, anything that looks like this is a test question, because these are the questions you're going to see in calculus. All right, so first thing we got to do is we got to rewrite this guy as, well, you got to rewrite him, first of all, you got to rewrite him as a product rule, because this right here is product. That means you're going to have to put it together. So What can we do with that 2? Well, that's log base 2 of x squared. Same thing here. This 3 can come out here, and we get log base 2 of x squared plus log base 2 of x to the 3rd power is equal to 4. Okay, we got the same bases. So we could say, you could use u substitution here. U squared plus u to the 3rd, but that we're not going to do it that way. We could distribute that 2. Try that. Distribute the 2, and then you get the next step. I'll pause the video while you look at that next step. I'm going to go with the u substitution. I said we might not want to do that, but I'm going to go with the u substitution. And I'm going to do this. I'm going to start the problem over. Remember when I said I wanted to do the u substitution, I said you might not want to do that? Well, I think you're going to, because if you try to do anything else, you're going to, I tried it a while ago on a piece of paper, it's going to be too long. U is equal to log base 2 of x. Therefore, we've got u squared plus 3u is equal to 4. U squared plus 3u minus 4 is equal to 0. U 1, 4, be a negative 4 and a positive 1. So u plus 1 is equal to 0. U minus 4 is equal to 0. And u is equal to log base 2 of x. Log base 2 of x is equal to plus 1 is equal to 0. Log base 2 of x minus 4 is equal to 0. Log base 2 of x is equal to negative 1. And that looks funny because that negative 1, that can't happen. Log base 2 of x is equal to 4. Now we've got a logarithm. We can rewrite it as a exponent. Log base a of x is equal to y. A to the y is equal to x. So I can rewrite this as negative 1 to the second, 2 to the negative 1, 2 to the negative 1 is equal to x. And here, I can rewrite it as 2 to the what? 2 to the 4th is equal to x. And 2 to the 4th is going to be 16. 2 to the negative 1, well, 2 over 1, that'd be 1 over 2. That'd be 1/2. So we'll have to check both of them and see what they say. I don't know if it's going to let me type in 2 or not. But u substitution is the way to go. If you try to do it another way, it's going to be too long. That's why I went ahead and told you to use u substitution. So it says use fractions to separate. So I'm going to say 1/2, 1 divided by 2, comma, and 16. Let's see what the answer is, because 2 and 1/16. Now, how did I get? Okay, I think I've got something written wrong. I might have transposed the definition of logarithm. Hold on. Let me pull up the definition of a logarithm right quick, because evidently I transposed the number, and if I did that, that's why I got the same letters, just different numbers. Same numbers, different answer. Definition of a log. And definition of a log will give us, where's the definition of a logarithm? There it is. Well, that's not the one I'm looking for. Where is the definition of a logarithm? Sometimes Google can be a pain. Definition of a logarithm. Definition of a logarithm. Well, definition of a logarithm. Definition of a logarithm is going to be well, right here. Here's the definition of a logarithm. Make sure I did that right. I'm going to a to the y. So a to the y. So let's look and see what I wrote down. So here's the two right here. A to the y. So okay, I did transpose it. A to the y is equal to x. Log base a of x. So x is equal to a to the y. That's going to be 2 to the negative 1. I still think I got it right, but let's see. Log base 2. I've got something transposed. And a to the y, this is y right here. I think I was calling that x. I might have not have been. This is x, and this is a, so that would be 2 to the 4th is equal to x. Okay, something's kinky here, because I got that and they said it was wrong. After looking at it, I know what I did wrong. It's at the beginning of the problem. U squared plus 3u minus 4 is equal to 0. I did the signs backwards. U, when I did the reverse FOIL, and that's supposed to be a negative of a positive 4 and a negative 3 and a negative 1. There we go. That's where I messed up. Here I had a negative 4, so all that's wrong. That's wrong. That's why I got the same numbers. That's why I got the same numbers, but different answers. So I knew something was wrong. So I'm going to take this and I'm going to redo this right here. Sorry about that. That's why logarithms are such a pain, because you can make one little mistake and it goes all over the place. And then you got to find it. Which I make mistakes. I'm just next is a good guy. I'm just as good as the next guy. I make mistakes like everybody else. All right. So u plus 4 is equal to 0, and u minus 1 is equal to 0. All right. So u is equal to 4, negative 4. There we go. And u is equal to positive 1. Now I can say log base 2 of x is equal to 4. Log base 2 of x is equal to 1. Now 2 to the 1 is equal to x. And this is a negative 4, sorry. And 2 to the negative 4. 2 to the negative 4 is equal to x. A to the y. There we go. And then x is equal to 2. And x is equal to 2 to the 4th, which is 1 over 2 to the 4th, which is equal to 1 over 16. There we go. So it was just a sign on the reverse FOIL that I missed. So I apologize for that, but I'm not going to say I'm perfect. I only know of one person that walked on water, and I'm not that person, so it's above my pay grade. So That would be the answer to that. So those last two questions were good test questions. So make sure you know how to do those last two. All right, that's all the questions for today. Sorry it took so long, but those are questions I haven't seen before, so hope that helps, not confuse you.